Hey everyone, and welcome. Today we're going to dive into a field of science that's pretty much set to reshape our entire future, and it all centers around something called World Quantum Day. So what's that all about? Let's get into it. Okay, so what are we looking at here? At first glance, it's just a number with a lot of weird symbols. But this is actually one of the most important numbers in the entire universe. It's called Planck's constant. And this incredibly tiny value, well, it's basically the line in the sand where the normal rules of physics just stop working and the super strange world of quantum mechanics begins. So that brings up a pretty good question, right? Why on earth would a number, of all things, get its very own international holiday? Well, take a look at the date, April 14th. If you write that out numerically, 414, you get the first three digits of Planck's constant. And believe me, that is no accident. That's right, April 14th is World Quantum Day. It's this awesome global event designed to pull back the curtain on quantum science. The whole point is to show everybody that this stuff isn't just some abstract theory for scientists in a lab. It's actually a powerful force that's already shaping our technology and, yeah, our future. To really get why this is such a big deal, we first have to understand the quantum realm itself. And this is a place where the rules of reality, well, they get a little weird. Okay, a lot weird. So here's the thing you gotta wrap your head around. It seems like our universe runs on two totally different sets of rules. You've got classical physics, which is for everything we see and touch. A baseball has one specific location, a car has one definite speed. It all makes sense. But when you zoom way, way, way down to the size of atoms and smaller, quantum mechanics takes over. And that's where things get really counterintuitive. And that brings us to our first strange rule, superposition. So imagine a coin spinning in the air. Before it actually lands, is it heads or tails? In a way, it's kind of both at once. Well, a quantum particle can literally do that. It can exist in multiple states at the exact same time, right up until the moment you measure it. Yeah, mind-blowing, right? And if you thought that was weird, hold on, because then there's entanglement. This is where two particles get linked together in this really deep, mysterious way. If you measure one of them, you instantly know the state of the other one, even if it's on the other side of the galaxy. It's so strange that Einstein himself called it spooky action at a distance. Now, I know what you're thinking. This all sounds like something straight out of a sci-fi movie. But it's not. These bizarre quantum rules are the real reason some of our most important technology actually works. The semiconductors that power the phone or computer you're watching this on right now, the lasers that read discs, the MRI machines that save lives in hospitals, all of them are powered by our understanding of quantum mechanics. So, if that's the technology we already have today, what's next? Let's take a look at how these quantum rules are setting the stage for some truly incredible new technologies. Okay. The next huge leap forward is in computing. Every computer we have now uses bits. You can think of them like a light switch. They can either be on or off, a 1 or a 0. Simple. But a quantum computer uses something called a qubit. And thanks to that whole superposition thing, a qubit can be a 0, a 1, or both at the exact same time. That one little difference unlocks an absolutely staggering amount of computing power. And with that kind of incredible power, we're talking about revolutionizing entire industries. I mean, just imagine being able to create brand new drugs by simulating molecules in a matter of hours, not years. Or building financial models that are so complex they're basically foolproof. We could tackle climate change with pinpoint accuracy or design revolutionary new materials we haven't even dreamed of yet. But hold on, the impact doesn't stop with just building faster computers. Those same strange quantum rules are also the key to creating a new generation of communication that is literally unhackable. So check this out. Here's how it works. You share a secret key, like a password, using these quantum particles. But because these particles are so incredibly sensitive, the very act of a hacker trying to spy on them, just trying to look at them, will change their state. That disturbance gets detected instantly. The key is thrown out and your message stays totally secure. It's like having a security system that's literally built into the laws of physics. So this is all super fascinating, right? But you might be wondering, why does this matter to me right now? Well, this isn't some far-off, distant future. The race to build a quantum future is happening as we speak, and the United States is investing very, very heavily. I mean, we're talking about a massive ecosystem that's being built from the ground up.
It connects government agencies like the National Science Foundation, world-class universities like MIT and Stanford, and of course, the big tech giants like Google, IBM, and Microsoft. They are all pouring billions of dollars into making quantum tech a reality. And what does all that investment in research actually mean for people? It means jobs, a lot of jobs. This huge national push for quantum is creating a massive demand for engineers, scientists, technicians, and teachers, a whole new generation of skilled professionals to actually build this quantum future. And this quote really just says it all perfectly. This isn't just about cool science experiments anymore. It's about real, practical innovation that is going to drive our economy and secure our competitive edge on the world stage. It's literally about building the next chapter of human progress. So, as we wrap things up here, I want to leave you with this question. If you had a machine that was powerful enough to simulate parts of the universe, to design miracle cures, or to maybe even solve our climate crisis, what's the first problem you would want to solve? The quantum future is coming fast, and it is full of incredible possibilities.